Today we are going to discuss some of the problems on convolution integral. First problem, consider a continuous time LTI system with unit impulse response h of t is equal to u of t and input x of t is equal to e power minus at into u of t, where a is greater than 0. Find the output y of t of the system. We know that y of t is equal to x of t convolution h of t. That is, y of t is equal to integration minus infinity to infinity x of tau into h of t minus tau into d tau. Then we have to plot input signal x of t as e power minus at into u of t. Then the graph will be e power minus at. We have to draw exponential signal with amplitude 1. Similarly, h of t is equal to, it is given h of t is equal to u of t, unit step function. Then the graph will be amplitude is 1. Now we have to plot x of tau and h of t minus tau with t is equal to 0. Then x of tau is equal to e power minus a tau into u of tau. The graph will be same. Says tau at 0. Signal will be like this. And h of t minus tau will be at t is equal to 0, we will get h of minus tau. That means mirror image we have to draw with amplitude 1. Here it is tau is equal to t or t is equal to tau. Now, if t is positive, that means it is forward shift. To h of t minus tau, and it is, if t is negative, that means it is backward shift of h of t minus tau. Then when t is less than 0, x of tau into h of t minus tau is equal to 0. We can find out it from the graph. Therefore, y of t is equal to 0 at t is less than 0. Now we have to find out when t is greater than or equal to 0. Then the equation is y of t is equal to summation 0 to t x of tau into h of t minus tau into d tau, which is equal to integration 0 to t e power minus a tau into 1 into d tau, which is equal to e power minus a tau divided by minus a, limit varies from 0 to t. Then y of t is equal to 1 by a into 1 minus e power minus at at t is greater than or equal to 0. Therefore, we can write y of t is equal to 1 by a into 1 minus e power minus at into u of t. Then the output signal y of t is equal to, we can draw the output signal as, this is t at 0 with amplitude 1 by a. The signal will be like this. This is y of t. That is the final answer for the given problem. Next problem. A continuous time LTI system has impulse response as shown below. Find its output if the input is x of t is equal to delta of t minus 1 plus delta of t minus 2 plus delta of t minus 3. The given signal is h of t is h of t is with amplitude 1. We know that y of t is equal to x of t convolution h of t, which is equal to delta of t minus 1 plus delta of t minus 2 plus delta of t minus 3 into h of t, which is equal to h of t minus 1 plus h of t minus 2 plus h of t minus 3. Let us draw h of t minus 1, h of t minus 2 and h of t minus 3. First h of t minus 1, that means I have to shift the signal h of t by 1 unit in right direction. That means the signal will start at 1 with amplitude 1 and starts at 0 with amplitude 1, h of t minus 1. Similarly, h of t minus 2. Once again, I have to shift h of t by 2 units or h of t minus 1 by 1 unit. Then the signal will be this h of t minus 2. Next is h of t minus 3. Then the signal will be like this with amplitude 1, h of t minus 3. So we have to combine h of t minus 1, t minus 2 and t minus 3 to get output signal y of t. Then y of t will be t, this y of t 0, 1, 2, 3, 4. So 0 to 1, 1 to 3 it is 1. This is y of t. Next problem, evaluate the following continuous time convolution integral and plot the signal. Plot the signal. Then y of t is equal to u of t plus 1 convolution u of t minus 2. Let x1 of t is equal to u of t plus 1, x2 of t is equal to u of t minus 2. Now we have to plot x1 of t and x2 of t individually. Then x1 of t is equal to u of t plus 1. That means we have to start it from minus 1 with amplitude 1. Minus 1 we have to start with amplitude 1. Then x2 of t is equal to u of t minus 2. That means I have to draw the signal from plus 2 with amplitude 1. This is x2 of t. Then y of t is equal to u of t plus 1 convolution with u of t minus 2, which is equal to x1 of t convolution with x2 of t. That is y of t is equal to integration minus infinity to infinity x1 of tau into x2 of t minus tau into d tau. Then we have to draw x1 of tau, that is, this is x1 of tau. The signal will be like this. with amplitude 1 and x2 of t minus tau. Then that is mirror image of x2 of tau. Then the signal will be at minus 2. Amplitude will be 1, 0. Now we have to find out when t minus 2 is less than minus 1, that is t is less than 1. x1 of tau into x2 of t minus tau is 0. Therefore, y of t is equal to 0 at t is less than 1. Next is when t minus 2 is greater than or equal to minus 1, that is when t is greater than or equal to 1, y of t is equal to summation minus 1 to t minus 2 x1 of tau into x2 of t minus tau into d tau, which is equal to summation minus 1 to t minus 2 1 into 1 into d tau, or y of t is equal to t minus 1 at t is greater than or equal to 1. Or we can write y of t is equal to t minus 1 into u of t minus 1. Then we can plot y of t as this is t, this is y of t at 0, 1, 2, 3, minus 1, minus 2, minus 3. With amplitude here it is 1 and here it is 2. Starts from 1. This is the final answer for the given problem. Next problem. Evaluate the continuous time convolution integral given below and plot the signal. Y of t is equal to u of t plus 2 minus u of t minus 1 convolution of u of minus t plus 2. Let x1 of t is equal to u of t plus 2 minus u of t minus 1 and x2 of t is equal to u of minus t plus 2. Then we have to plot x1 of t and x2 of t. Then x1 of t is, the signal will be 0, 1, 2, 3, minus 1, minus 2. Amplitude will be 1. The signal will be present from minus 2 to plus 1. This is x1 of t. Similarly, 0, 1, 2, 3, minus 1, minus 2, and the signal will start at plus 2 with amplitude 1 and so on. Then y of t is equal to x1 of t star x2 of t. Then y of t is equal to integration minus infinity to infinity x1 of tau into x2 of t minus tau into d tau. Now I have to plot x1 of tau. x1 of tau is 0, 1, 2, 3, minus 1, minus 2, minus 3. Signal is present from minus 2 to plus 1 with amplitude 1. Then x2 of t minus tau is at 0, minus 1, minus 2. That is the mirror image of x2 of tau. With amplitude 1. Now, when t minus 2 is less than minus 2, that is t is less than 0, we get y of t is equal to integration minus 2 to 1 x1 of tau into x2 of t minus tau into d tau, which is equal to integration minus 2 to 1 into d tau. Then it is 1 minus of minus 2, that is equal to 3. Therefore, y of t is equal to 3 when t is less than 0. Next is when t minus 2 is greater than or equal to minus 2 and t minus 2 is less than 1. That is 0 less than or equal to t less than 3. Then y of t is equal to integration minus t minus 2 to 1 x1 of tau into x2 of t minus tau into d tau, which is equal to integration t minus 2 to 1 into d tau, or y of t is equal to 3 minus t at 0 less than or equal to t less than 3. Next condition, when t minus 2 is greater than or equal to 1, that is t is greater than or equal to 3. Then x1 of tau into x2 of t minus tau is equal to 0. Therefore, y of t is equal to 0. Then, summarizing the result, we can write y of t is equal to 3 at t is less than 0 is 3 minus t, 0 less than or equal to t less than 3, and 0 when t is greater than or equal to 3. Now we can plot output signal y of t as y of t 0, 1, 2, 3, 1, 2, 3. So the signal will be and so on. This is the answer for the given problem.